In the last video for the mock exam review 2016-20, we calculated step number A, which was the total impedance. Now we're ready to calculate the total current that will be passing through all three components in series. By definition, I total is equal to V over R. However, since we're using AC circuits, we have a new formula. We say V total, which is an AC component, the power supply, or VS, over Z total. And we know that both of these have phase angles to go with them because the voltage and the current are not always in phase. Now, for the power supply, we always assume, most of the time, we assume that the voltage has a phase shift of 0. So we have 10 volts, and we assume that is the reference angle. And the Z that we calculated was 435 ohms, and we came up with an angle of negative 60 degrees. Okay. After we divide those two components together, 10 divided by 435, I get 0.0298 and so forth, okay, which I can easily translate that into 22.98 milliamps. Now I have to look at the phase angle. Well, since I'm dividing angles, there's a rule of vectors where if you are dividing angles, you take the top angle and you subtract the bottom angle. So the top angle is 0 degrees, and I have to use the subtract formula, and the bottom angle is negative 60. Well, following the rules of algebra, if you have a negative subtracted by a negative, you'll end up with a positive. So the angle that I'm using is a positive 60 for the results. So the final answer that I will write on my paper would be 22, or really 23 milliamps at a phase angle or a phase position of 60 degrees. That tells me that the current is leading the voltage by 60 degrees. So when the voltage is going through its cycle, the current has already begun its cycle in advance, and it has gone in advance by a phase shift of 60 degrees relative to the 360 degrees for the total time period. That's what that means. Okay. In the next video, we will calculate the voltage drop across the R1 resistor.